Hi, so welcome back to our channel again, and this time we have brought to you a special topic in the field of semiconductors and the VLSI. When you design an ASIC application-specific integrated circuit, or in a short form, we call it a IC, we basically see that these nowadays the modern integrated circuits are low power designs. So what is the low power design is the topic of today. So we know that when we talk about low power design, nowadays we have battery operated devices, wearable gadgets such as our smartphone, smart watch, smart ring, etc. And about in this category, we talk about they are low power design. It means they are battery operated devices and the chips inside are the battery operated. They draw the power from the battery. So the practice in the industry is to make sure that the batteries are useful for long durations of the time. So low power design is about reducing the overall dynamic and static power consumption of an integrated circuit. So whenever you see any circuit, especially the digital circuit or switching circuit in an IC, there are two types of power. One is called as dynamic power and one is called as static power. And the aim of a designer is to reduce both of these quantities to bring down the overall power in an IC. So dynamic power is composed of two parts. One is switching. Due to the switching, whenever the digital circuit changes states from 0 to 1, you have a switching action and there is a short circuit. Whenever the switching happens, there is a power called dynamic power and then another is the short circuit. In the static power category, the power consumption comes from leakage. Even when your circuit is shut off or is not doing any activity, there is likelihood the current is flowing through the devices, and that is called as leakage that gives rise to the static power. Second component is the current flowing through the transistor when there is no activity, as I said. So let us understand all these components of the low power design and how the trade-off can be done to minimize the overall power consumption. So here in this picture, you see a very fundamental block in a CMOS IC design, that is a CMOS inverter, and we have covered the working principle about of this circuit a lot of times in our tutorials, so refer to that. So we see this is a PMOS, this is an NMOS. PMOS is clearly seen because there is this bubble right over here. And when you see that the gates of the transistors are tied to each other and you have a digital pulse switching from 0 to 1 coming as an input to this circuit. Output of this circuit is driving a capacitive load named as CL, and the output is taken across this capacitor when the capacitor charges and discharges, and the output is inverted form of the input. You see the logic 0 to 1, and here output is logic 1 to 0, and the cycle continues. Here is your power supply VDD, here is your ground. This is also a CMOS circuit, but this time we have tied the gates together to the ground potential, and the circuit is not in the on state. Rather, you have a diode here, and then there is a direction of the current flowing through that. Now let us understand what all factors contribute. The first is the alpha, which is the activity factor. For example, your circuits inside the IC is going from 0 to 1, making transitions, processing data, etc. F is the frequency, that is the speed of the circuit, how fast your switching is happening. TSC is the transition time when your logic switches from 0 to 1 or 1 to 0, that it takes some time. VDD is the power supply. I leak is the leakage current. I peak is the peak current. So now all these factors constitute, when put up in an equation, constitute a power equation, total power equation for a switching circuit in CMOS IC design. So here in the top, you see that the total power is composed of three factors highlighted in different colors: red, green, and the blue. And when I refer to the first component in the red is alpha F Cl and square of the power supply VDD. So the aim of the designer is to reduce the overall power consumption by reducing all these three factors. And in each factors, let us understand how to reduce the particular component power consumption so that we have the low power design. So in the red, when your inverter, this is a CMOS inverter, is accepting the input from 0 to 1 or 1 to 0, it is transistors are switching, the working principle we have explained, and your capacitor is continuously charging and discharging. For example, when the circuit is switches from 0 to 1, input is switching from 0 to 1, NMOS is on and PMOS is on. No, when you have a circuit is at the logic 1, NMOS is on and the output is PMOS is switched off, right? So your capacitor is like your output is connected to the ground because capacitor discharges through this NMOS. When you have a logic 0, PMOS is on and NMOS is off. So the output is connected to the VDD, and that is how you see that there is a current flowing from power supply to the capacitor, making it charge. So in the red arrow shows that this is the dynamic when the switching is happening. The power that is consumed by the circuit is called as P switching power, which is alpha F Cl and square of the VDD. So you reduce the power supply voltage, you have a lower power consumption. Your load, capacitive load should be low. Frequency, if you don't have a high speed circuit, then you have a lower power consumption. But nowadays we have a very fast processor, in the gigahertz and all those frequency range. So obviously the frequency is the matter of concern, because with increasing frequency your power goes up. Now look at this circuit. Before that, there is one power term in the green, which is product of TSC, VDD, and I peak. So your aim is to have a lower power supply voltages, that is VDD. Then transition time should be as low as possible. Peak current should be as low as possible. So you can reduce the component in the green right here. The final part, your circuit is shut off, it's not doing any activity. So still there is a power consumption, very small, and that is due to the two components, because your supply is connected and there is a leakage. Your components are not ideal, devices are not ideal. So that's why you have a power equal to voltage into current. The leakage current contributes to the power, which is the third term here. So you see, this is how you can take measures to reduce the power consumption. So all these factors like frequency, supply voltage, leakage, load, that is the capacitive load, activity, transition time, peak current, they are all the factors influencing the power. And there are techniques to understand and reduce this power. So higher the voltage, higher is the power. Lower the voltage, lower would be the power. Therefore, trade-off will be required with applying the techniques. Okay, so I hope you understand the basics about low power design, why it is required and how it is done, with the example of simple switching circuit, that is CMOS inverter. If you like this video, share it with others, like and subscribe to the channel, make the comments about what would you like to see more, and we will present you that. Till then, stay tuned. Wish you happy learning.